So my name is Rachel Wood, and I am the Key Stage 2 Maths Advisor and Trainer here at Twinkl, which I've been doing for just over a year now. And hopefully this afternoon looking at questioning in primary maths, so Key Stage 2 specialist, but obviously hopefully some of you might be in Key Stage 1, some of these skills can be used there as well. And hope you have a lovely time. So please put questions in the chat, as Emily said, and they'll be monitored towards the end as well. Okay, so a little bit about me to start with. So I am Rachel Wood. Prior to working here at Twinkl, I was Key Stage 2 teacher for 18 years. Most of that time I was maths lead across 2 different junior schools in Southend and Essex, where I'm from. And over those years, you can imagine lots of changes to maths curriculums, expectations, SATs, etc., and lots of changes as that's happened. As well as working for Twinkl, 2 little boys. They are 2 and nearly 5. They love maths already, I'm pleased to say. So nice to see their maths journey starting as well. Bit of a cliche here, I know, but I really am passionate about maths. I truly believe everybody can succeed in the subject with the right support and teaching. I think there's a lot of sometimes anxiety towards maths. And I think us as practitioners is creating that ethos where everyone can succeed. And questioning obviously is an integral part of that. Hope some this afternoon's information can help your children in your classes. Okay, so look at our sessions. We'll try our introduction. We'll try and define what effective questioning is, if we can actually define it. Is it something, or is it a whole matter of lots of things? Think about why it's important in mathematics, the different types of questioning, the styles of questioning. Just some resources we have here at Twinkl. I hope at the end some time for questions as well. So we are talking obviously about questioning. However, before we can actually talk about questioning, let's think about mathematical talk. The NCTM, obviously lots of us use on a daily basis. A lot of our work here at Twinkl is using NCTM research all the time and thinking about how we can use that in our resources we present within our teaching. So before we think about questioning, onto a mathematical talk. So the NCTM says, expressing mathematical ideas orally help children to build communication skills. Can also form an important part of developing understanding mathematical concepts and the ability to reason mathematically. They identify 4 ways we can improve our talk in the classroom. So before we can think about children answering questions, we need to create a culture and an ethos where children can speak mathematically, whatever age they might be. We don't want those silent classrooms. We don't want those classrooms where people aren't actually talking about their maths. So we want them to answer questions. They need to have the skills in which to speak confidently mathematically. So they say, expectation of mathematical talk. They have to know that we're going to talk mathematically in our classroom, in our groups, in our pairings. We're going to use correct vocabulary all the time, aiming high, using the correct vocabulary, whatever age they might be, having the vocabulary displayed, spoken all the time, making sure they are using that correct terminology. So when we are asking them questions, they know to use them correctly coming back to us. And support them in that talk, because obviously you don't know what age your children are in your class. My little ones have just started reception. I'm hearing mathematical language from him all the time. Also, you might have year 6 who are reluctant to talk about mathematics in that communication, having the confidence to use the vocabulary. Because obviously we have reluctant talkers. So we have ones who will sit there, let everyone else talk around them. We have ones who will obviously want to constantly answer, and the ones who are less likely to want to volunteer for various reasons. So having the place where you can talk with the vocabulary and think it's okay, we can make mistakes, that's how we learn, and having that culture. I'm going to think about that 3rd one just to start with before we move on to questioning in more detail. So supporting them. Having some generic sentence starters, almost having that little cushion, if you like, that they know how they can express their ideas. And all this time it's practicing this all the time. So say, I agree with you because, disagree because, if I know this, then I know that. So if I know that 2 times 5 equals 10, then I know that 5 times 2 equals 10. It's getting that generic sentence starter. So when they're asked questions, they have a rough idea of sort of how they could answer it. And from that, we have the STEM sentences or sentence stems, however you want to call them, giving those key concepts generalizing them, a template for discussion, because they don't just talk mathematically out of nowhere. They've got to have the skills. They've got to be equipped with doing them. So when you ask effective questions, they've got something, they know how roughly how they could answer it. That comes from mathematical talk in pairs with you, modeling it all the time, modeling my turn, your turn, and having that to and fro conversation. They said to me, disagree with that answer. I used to love it. Like, let's talk about it. So you've got that communication. Helps their communication skills, and hopefully makes them have less anxiety towards the subject as well. Okay, but questioning is our title today. Some of you who might be as old as me might remember Teachers TV, which came out, and things were on television and we could watch various things before TeachMeets this existed. There's a little very short snippet. We were trying to define what effective questioning is. I'll mute myself. It's a very short, few ums and ahs too. So we'll watch.
Effective questioning. Right, hold on.
Have you got any questions on effective questioning?
Making sure something's gone in.
Opening the door to misconceptions.
I think that's one of the key things for being a good teacher.
Let the students ask the questions.
Effective questioning.
Good question. Good question.
Waiting a long time for an answer is really important, actually. You're supposed to give them lots of time.
Testing understanding. Opinions are more important than right answers.
Giving pupil confidence.
Letting them come up with the answers.
Effective questioning.
It happens in every lesson, doesn't it?
Choosing the right words at the right time.
Bloom's taxonomy.
Keep things open.
Keep it fun.
An essential skill for a teacher.
Okay, there's a few other things there, because trying to define it is actually quite difficult, because I personally believe effective questioning encompasses so much. It's not just one type of question. We've had a few things there: keeping it fun, opinions, weighting, we'll talk about that a bit later, discussions, Bloom's taxonomy, so many different things coming in. Actually, effective questioning is huge. It's about a way of your classroom. And there was one little thing that one person said, I'm talking about here, about effective teachers. Just have a little think while you're thinking this session. Does an effective teacher ask good questions, or are you an effective teacher because of the questions in which you ask? And is an effective teacher, as at the beginning about mathematical talk, you need somebody to answer that question. So effective teacher is not only asking those questions, it's creating a place where they can answer them as well. So they've got those times to think about it. So is there any question and answer, and put in the chat? So a little think to yourself, is what makes it, is it you, the teacher? Is it the question? Because anybody could ask the questions, but it's how you ask them. Is it how you lead on for them? Is it the class, or how they've been molded by you, the vocabulary they use? Is that dialogue back and forth? Someone also said to me, it's them asking the question, it's not you. That's an interesting viewpoint as well. Can they ask really good questions back to you with their learning? Little aside there. Okay, so types of questions then. We've got, this is a fact I saw, scared me a little bit. Apparently, the average teacher asks between 300 and 400 questions every day. Right, it's every 2 a minute. No wonder we're exhausted in the day. Those questions back and forth we're asking. Actually, 300 and 400 questions every day, which is a huge amount of questions we're asking. Obviously, not just in maths lessons, across the board. In 1986, luckily we have moved on from then, only 93% of those were lower order. And that's a scary thought. That at the time was just basic recall facts. We have moved on a great deal from that. But sometimes I think, are the questions I'm asking, are they just recall, or are they actually having to think about simulating mathematical thinking? Are they open problems? Are they investigations where they're actually having to not just think of an answer and bounce it back to you, they're actually having to go deeper? Our instincts tell us we should be doing more investigative maths, but sometimes when we try something, give it a go, we may be upset with the response. We're thinking about maybe thinking, oh, I didn't go quite well, so don't do it again. It doesn't go well the first time, you try again. It might not work the first time because they're just inexperienced at it. They're not used to being responsible for their decision making. They're not used to having to be systematic. They're not used to not being told what they need to do. Often we might model a method and then they do the method in maths. This is how we answer it. Your turn. Yes, that's obviously really useful, but they're always just doing that. They haven't got to think for themselves. Then when they are given an open-ended problem, they panic because they're not used to doing it. So it goes wrong the first time, do it again. We tell the children mistakes are really useful. Us as teachers, taking a risk, because we might not have the questions right yet. We might not be stimulating their learning because we're not used to doing it. So if something doesn't go right the first time, try it again. But open-ended, deep questions are actually having to think and use and apply their maths. They're going to get stronger at it because they're going to have to be responsible for their own learning. We want that. We want children to be independent. Leave us in year 6, independent mathematicians to go on to secondary school and beyond and see the real purpose of maths in life. Starter questions then. There's a little image of one that we've got on slide I'll refer to at the end. But these are open-ended questions which focus on children's thinking in a general direction and gives them a starting point. So I'll talk about people being reluctant talkers, giving them a starting point, letting them go, right, how could you sort these? If you're working in reception, my little boy is, buttons, how could you sort these buttons out? How could you sort them? So I might say, well, there's different colours. Okay, or they've got 4 holes and 2 holes there. Okay, how could you sort these numbers? How could you sort anything? There's an open-ended question, but they're on direction, they're learning off themselves. How many ways can you find 2? What happens when we? What can be made from? How many different can be found? So general direction questions, so they can use, you can use in different forms, so they're used to them. Just do it once, it's new to them, they don't know what to do. If you do it more and more with different aspects of maths, become familiar with it. And you can start to see how, as a person said there, you can reasoning behind it. Thank you for that. There's a little picture there. It's one of our early morning starters we got at Twinkl. There's a rectangle there. And the bubble says the perimeter of this shape is 94 centimetres because 40 millimetres is 4 centimetres. Do you agree? Explain why. So it's a reasoning question. And obviously they had to do perimeter. They need to know what perimeter is, they need to know their conversions. And you can imagine giving it to the class and go, off you go. And how can we start it? Well, someone might say, 40 millimetres is 4 centimetres, so therefore mathematical talk being used. I know that's 4 centimetres, and a rectangle opposite sides are equal in length, so the opposite side is 4 centimetres. That side's 9 centimetres, the opposite side is also 9 centimetres. So they're already using that talk. They're not sitting in silence, just adding up sides for perimeter of a rectangle. They're actually having to use their reasoning, property of shape, conversions, and really talk about it. And then somebody might say, well, I disagree with the answer. Like, brilliant, why is that? Someone might say, well, I think that side's 9, add 9 together, that's an 18. And I've got 2 4s because that's 4 centimetres. So that's 8. And I add those together and get my answer. I disagree. Somebody else might say it in a similar way to you. However, I did 9 plus 4. Got my 13 and doubled it to get a 26. So one question has created so much mathematical talk, open-ended, having to use all the skills they've got, but in a much more open way, rather than just giving them a page where they're having to add up size of a rectangle. Which yes, they need to know perimeter. However, how many times do they need to do that? So I think questions all about varying the type you used, or a variation in question all the time. Mathematical thinking, we need to stimulate that because otherwise it becomes something they just do. We don't want children just to do maths, we want them to become thinkers. So in parents evening, I've heard, I'm sure you have as well, so what's the point of this? Didn't do this in real life, don't you do this now? We want to create mathematical thinkers who are going to challenge things, who are going to try and understand the best value or the cost of something and really be thinkers, not just doers. So these questions are so important because they assist children to focus on particular strategies. Helps them see the pattern, the relationship. If they're a little bit stuck, it can help them. I love maths because I love seeing pattern. I love seeing when the links between things. And when you see a child understand the relationship between what's going on, it's just, it's nothing like it. because mathematics has got that aspect, that pattern, that follow, the rule. You can use that to help you solve that. If I know that 2 times 5 equals 10, I know that 20 times 5 equals 100. I've used that relationship, not just knowing off by heart. So these questions are, what's the same, what's different? I've seen this being done in early years, as with a picture. What's the same, what's different? So having to think, having to actually look and what's the same, what's different, not just accept it, having to really challenge. So you could do this with any age range. What's the same, what's different? Can you group these in some way? Shapes, numbers, whatever it might be. Can you group them? How would you group them? What would you do? And you can see how they're also in charge of their own learning. They're responsible for their own thinking. They're having to think for themselves, not just answer a question that you've set them with one answer. Often they find this difficult to record their results. And some children like to draw a picture, some children like to do a table, doesn't matter, but have something that they can write on, a whiteboard or a bit of paper. Jotting is so important. I'm always doing that, jotting things down to record. Then when they've recorded something, like to manage how they've done it. Can they see the pattern? What would happen if a little girl there, picture with those 6 cakes? What would happen if 2 were taken away? Could say to key stage 1. What would happen if you had to share them between 4 people? Would there be a problem? What would happen? Oh dear, there's a done. What would happen if you ate 2 of them? What would happen if you got 2 more? And you just start to see how questions they're having to think, and they were much more engaged, much more excited. Bring real cakes to them, really excited. Can you see a pattern? How can a pattern help you? What comes next? Why? So this little one, and the last point here, I'm going to show you a little clip. Got lots of videos on the site, the concept videos. They're fantastic, all different subjects. The maths ones are really aimed for year 6, stats preparation. They'll also be used across the key stage. Key stage 1 are being produced as we speak. So a little short clip of one about this. What do you think comes next and why? Little twist on a number sequence. So it's only short. Meet myself in a little watch and see what you think.
Your turn. Can you find 2 different numbers for each of these sequences to complete them? All complete? Well done, here are your answers. The sequence beginning 25, 50 could be completed using the additive relationship, adding 25 each time. This would mean that the next number in the sequence will be 75. The sequence could also be completed using the multiplicative relationship, multiplying by 2 each time. This would mean the next number would be 100. The sequence beginning 9, 27 could be completed using the additive relationship, adding 18 each time. This would mean the next number in the sequence would be 45. The sequence could also be completed using the multiplicative relationship, multiplying by 3 each time. This would mean the next number in the sequence will be 81.
Okay, so you can see how number sequence can give different answers. And I would love to give your class those 2 sequences and say, what's next? And it's amazing, who does the 75? Who does the 100? Does somebody come up with both reasons? We're trying to create, see, mastery now, classrooms. We've got mastery there. Somebody could say, well, I think it's 75 or 100, because they're going deeper still. So rather than just doing a page of number sequences, they're having to think, what could it be? What could come next? Is there only one answer? So you're pushing them to really think about the mathematics behind it. And then you could go on to think about what's next. We followed that rule, what's next? But think about the ratio of the numbers. So obviously if they're multiplying, numbers are going to get larger quicker. They're going to get really big soon. Why? Can you predict the 4th term, the 7th term? Is there a rule? What can you do? And there's so much, rather than just doing more and more work. We used to think of quantity. So about the quality, picking questions that are really going to challenge, extend, deepen and allows you as a teacher to really take those children off and really push them on. Okay, now a couple here. Odd one out and true or false. So odd one out is fantastic at any age. You have ones on the left there, so you've got 8, 51, 77, and you challenge them. What's odd one out? Anybody like to give an answer at all? What's odd one out? Very good. So someone might say, well, I think 8's the odd one out. Fantastic. It's odd, others are even. Lovely. Yeah, so odd and even there you have. Someone also might say, well, I also agree with 8, but it's a cube number. Other two aren't cubes. Someone say, okay. Someone also might say, a single digit, brilliant. Someone might say 51. Other two round up, 51 rounds down. And you've got umpteen answers. So you can think how one very simple odd one out question could be used for so different things. You could have shapes, you could have anything in there, but they're having to explain their reason. And you can, once again, with the mastery, you can say which children are going to go deeper, who would say odd and even, or who would go for a different reason. Think of more reasons. True or false, another great way of showing and understanding. Algebra is in year 6. It's been made, it never used to be just year 6, but it's there now. And sometimes people get scared of what algebra is. If you have a true or false question, always taking away, they've got 2 options. They can choose one, and if one's going to that reason. So you've got A equals 10, B equals 5. So A plus B equals 20. True or false? What's your reason? So I might say, I think it's true. Why? Oh, I don't know. Let's think about it. I'll say, I think it's true because I'm going to substitute mathematical language and the letters in. So I've now got 10 plus 5 plus 5, that equals 20, because I know that 10 and 5 is 15 and 5 more equals 20. Someone also might say, well, B plus B, well, that's 2B, because in algebra, I've got 2B put together. So 2B is 2 lots of B, 2 lots of 5 is 10, 10 plus 10, oh, that's 20. So by posing questions like this, they're being responsible for their answers. You obviously have high expectations of your class, so you're challenging them to answer in the best possible way. And because the whole class are listening to it, ones who are reluctant maybe to give an answer have heard that fantastic mathematical vocabulary, mathematical knowledge from the class and from you modelling and guiding their discussion. Right, ideal possibilities. Obviously, these questions have been around for lots of years. There are many with ice cream cones and football cones and lots of different things. They're trying to find different combinations and or possibilities. This one was taken from a White Rose question I saw, which I've adapted. We've got Alice baking 120 cakes. She's selling them at a cake sale. So once again, maths in real life. This could really happen. It could be a cake sale at school, might be children familiar with it, giving it a real life context. She's transport these cakes to the school. Obviously, bake them at home, take them to school. Makes sense. She needs to choose one size of box for the cakes. Boxes need to be complete. Which box could she choose? On the bottom there, how many possible answers can you find? So some children would love this question, be off, write them off. Others will, oh, I don't know where to start. Some might need an actual box. Might need an actual box with maybe little blocks representing cakes and actually physically do it. The concrete approach. That's fine. Some children need that. Some children can picture it. They might draw little pictures. Some might need the actual box and the actual, ideally cakes, but probably wishful thinking. A little block represented. So questions that could come from your discussion. So you could pose this, and as a teacher, now you're being a facilitator to their learning. You can go around and really ask deep questions and watch them work. So you might start with them. What is the problem? Explain it to me. And that can also be used for anything. If they can tell you what they need to do, what the problem is, then they're halfway there. If they go, oh, I don't know, then you need to more work with it. What skills do you need? Any patterns you can start seeing? Start using that terminology. if you get 12 cakes, would that help you? Some people say, oh, I think it would, because since 120 is 10 times bigger than 12. So then I could think about what makes 12. So 3 lots of 4. Oh, that could help me. I love the word convince me the problem, because that's always putting pressure on them to really think of a great answer. Convince me that 80 wouldn't work. Convince me. Someone say, well, it doesn't. Well, why? Hopefully then I can think about, well, if I've got 2 lots of 80, I've got 160, that's too many. Oh, I've got 1 lot of 80, I've only got 40 left over. Can't have any empty space in the boxes. So thinking about the problem. Appropriate answers. What's the most appropriate answer? Because we want this to be real life. Maths in real life, that's what we're trying to get all the time. What's the most appropriate and why? Times tables, how would it help you? How do you do it? Start, where's your starting point? Do you draw a table? Do you think about them in numerical order? Do you think about, I'll do 10 first, does that work? Do you just choose random ones? What was your logic? The box you'd like there to be and why. So answer together, someone might say, I did this, I chose 2 boxes of 60 because I know that 60 are 620 and I've got 2 boxes. So now I said 10 because I can do 12 lots of 10 is 120. So about the appropriateness, discuss it. Someone might say, well, I think 2 lots 60 is correct, but I've got a box, mum's got a box, take them into school, it's easy in 2 boxes. So I might say, well, actually, I think the 10 is right, because if I dropped a box, I've only lost 12 cakes. If I drop 1 whole box of 60, I've lost half an hour of cakes. And you can see how one very quite simple problem of cakes in a box has got people thinking about the reasoning behind it. And someone might say, actually, I'd like just 1 box. I'd like 120 box altogether going in as 1. And someone might say, well, I've missed out 40. Got 10, 20, 30. There's no 40 there. Why is that? So you've got to see how people looking at patterns can have a whole discussion about it. Okay. Right, assessment questions. I'm not thinking the dreaded SATs test. Obviously, that's always the back of our mind for May. Assessments all the time. We want to know what the children are doing, how they're getting on, how they're thinking. So these are where to explain how they got to their solution. So on with the box question previously, how did they get to that answer? Did they get them all? Were they methodical? How did they get there? What was their thinking? So what have you discovered about this? Now, this question can be used for anything. How did you find that? Why do you think? So back to the number sequence question. Why do you think the answer is 75? Why? What have you done to get that? Why did you do it that way? Why did you use that operation? What made you decide to do it that way? I actually love asking that question to children. It's often they're thinking a different way from me sometimes. I'm like, wow, I hadn't thought of that. And that's how all the children can learn from each other as well. And then the discussion question. So after you've asked them their particular ones, you can bring the class together or a bigger group. And everyone together, the class, the prompt, the effort, sharing the comparison, talking about the solutions. It's their thinking. Because they've got to evaluate their work. So if they've done a piece of a problem, whatever it might be, a multi-step problem, it could be anything, evaluate how they've done. They've got their answer wrong. That's okay. We learn from our mistakes. So they've evaluated their work and they made a mistake. Was it calculation error? Had they used the wrong operation? Had they not answered all the question? Had they not all done all possibilities? It's thinking about how we're doing it, how we're evaluating our work. It was the same answer. Pattern group. And who's got the same? Some people say, oh, yeah, great. Check the numbers now. Oh, they've got the same as me. Oh, okay, yeah. I'll put my hand up now. It's got a different solution. And for someone to say, my answer's different, and have that confidence because you've trained them in mathematical talk at this very start, confidence to say I've got a different answer. And if it was a wrong answer, they've shared what they've done. And maybe they can, some of their strategies might have been better than what the other people have got. One error went wrong. Never mind. Everyone got the same. Number sequence, beginning, additive, multiplicative. Has everyone got the same? Who did additive? Who did multiplicative? Who did both? And if possibilities answered all of them, have you got them all? How can we prove we've got them all? Convince me you've got them all. How else can we do it? I think we used to, I think I talked to my mum in particular, she said, oh, we just did what we were told. We just added up. We didn't ask why. We just did put the number there and we did that and we did that and got the answer. We didn't ask why. Great if you got the answer. But if you didn't get the answer right, you're thinking, well, I don't know what to do. Now it's how have we done it and really talking about it. Less questions as such, but really deep, challenging questions. We've got the best solution. And that might always be the same one. One with the cake, for example. Someone might think, 10 is best. Someone 60 is best. As long as you can reason it, then it doesn't matter if you've got a different answer. And you want to create a class that can disagree respectfully and actually have a great debate. That's how we learn, isn't it? Okay, slightly different now. This is a recent strategy someone showed me that I share with you. I've done basketball question before, but never called it this before, so I thought I'd share this. Pose, pause, pounce, and bounce. So we might have heard of it, might use it already, but if you haven't, this is a little thing to try maybe tomorrow morning. Pose a question, pause, pounce, and bounce. Pause. In that first video on Teachers TV, someone said you should wait a long time. It's very true. The idea of wait time was first coined in 1972 by someone called Mary Budrow. And she did a study into how long teachers wait before jumping in with an answer. And right, the average in 1972 was 1.5 seconds. Right, that's the average time teachers waited. If you think it's not very long, 1.5 seconds. That's it. 0.1 second apparently was recorded. I mean, that is not even giving them a chance to breathe, let alone answer. And obviously, I'm not saying you sit there for half an hour with one question while a child's sitting there in silence looking around the room. But also, you need to give them sufficient time. If I'm asked a question, I need time to process it. Maybe do a little jotting on my whiteboard and actually think about how I'm going to explain the answer. And so if it's a times tables question, a quick recall, that's very different. But if it's a problem-solving question or explain, for example, the number sequence one, I would need time to actually look at those numbers and really think what I was doing. If someone just jumped in on me and go, oh, never mind, next person, I'd have felt really deflated. And the idea of someone being picked on is just everyone, is terrifying. If you pose the question, they've all got a chance to really think and then not literally pounce. I think it's rhymes with bounce why they use it, but ask somebody to volunteer an answer, or if you may have seen something on a whiteboard that you think is a really good explanation, you might ask them to volunteer. And then hopefully from that, you've got someone in the class who wants to comment, agree, disagree, but you've created that culture where it's okay to do that or bounce back to you to throw another question out again. So rather than you firing 400 questions every day, you're firing less because they're actually firing them back to you and, or more importantly, to each other. So different strategy, you might want to try that. Okay, so we've looked at mainly orally work here, talking, answering, vocabulary. But obviously at the end of the day, they are going to have to answer written, worded questions. So I thought I'd put this in as well to help, especially those of you in year 6 who preparation is sure underway already. And also for anybody who's answering worded questions, because Gareth Metcalf, who you might have heard of, is from IC Maths, is his company. He, along with others, have found that we've come so far in our Key Stage 2 maths. Obviously, the papers always seem to be evolving every year. Things can change. But I think at the end of it, we all still see multi-step worded questions being difficult, hard. Probably all the words, and sometimes they go, and they get flummoxed by it. And sometimes there's this nerves come into it, mass anxiety comes into it, and it's just that panic mode where they know how to do the calculation, but put it in a few words and put in a few multi-steps, and it just, something goes wrong. Sometimes they're just too keen and quick to answer. I've got a few in my head of ones I've taught over the year who just rush and think, oh, they can do that. Why didn't they read it carefully? Or they skim it, look for a few numbers, might see the word all together, or they might see the word more and then, oh, add them together, that's it. That wasn't the question at all. Or they might have missed a valuable part and they just make an error because they haven't read it correctly. And they go, oh no. Quite often they're the high flyers who finish the test paper first, and you go back and say, read it again. Go, I have done. So what Gareth Metcalfe suggests is that you deconstruct a question. This little video from his site of him showing how he's deconstructed a SATs question. So a little what?
So we're going to have a look at deconstructing this question from the 2022 SATs test for Year 6 in England. How can we get children seeing the deep structure of this question? First of all, in making this video, I've just recreated that exact same question, but I've just made it so it can be edited. Then I've removed a lot of the information. So I've just given that initial rectangle and I ask, what are the coordinates of point P? That's the question. And at this point, we're saying, well, what could they be? Give me a realistic estimate. Having generated those realistic estimates, I'm going to add some more information in. The length of the rectangle is 3 times its width. Now, would you edit that estimate at all? Now we've got this kind of benchmark to work from. I'm going to introduce almost all the information apart from the actual coordinate on the second rectangle for children to process. And we can look, well, what will I need to do to calculate the Y coordinate? How will I do that when I'm given that information? What about to calculate the X coordinate? What will I do then? And then we think about the deep structure before we get to the answer. And finally, I'll give all the information that's required, go back to that original question to be able to answer the question itself.
Okay, so you see how just taking it away and they had to estimate, because I'm sure a lot of children, probably me included back then, would have read the bottom question first and then almost then looked up rather than reading the top bit, next bit, looking at the graph and then reading the question. We're so quick to what actually have I got to do? What's the question? They looked at that, okay, and almost rushed on. If you take away some information, they've got to really study it. Estimating in maths. I used to always say to my class, does that answer look right? The cost of a lollipop, a newspaper and a book, £500. Could that actually be right? Is that really an estimate? Oh, it doesn't really. Does it make sense? So with this question here, I'm taking all this information about and that estimate, what could it be? And then giving some more information. You're having to almost predict what you need in order to answer a question. So by taking away things, they've got to be really critical. They can't answer it yet. And for some children, it'd be really irritating. Oh, because they've got to slow down. Got to calm it down and read it and take away everything else around us. Look at that question. Now, this is a lot of information on this slide, so you've got all the information in the document afterwards. But this is a research paper, quite a recent one, 2019, that was done on this, basically what Gareth Metcalfe has talked about removing opportunities to calculate. So taking away the information actually improves their performance subsequently because they'd almost been trained that they've got to slow it down, not just rush it and try and solve it too quickly. They said revealing a question gradually limits the amount of detail, and that can reduce maths anxiety as well, because all those words, all the diagrams, can be quite overwhelming, making it impossible to answer straight away. So they're forced to think about the structure. They're forced to think of what I need to do. They can predict the information. What? I can't answer this question. Why not? If it might be, I don't know, a house that's gone up in value, and you've given the final value. Well, I can't answer it yet. I don't know what it started off being. Oh, okay, they show the first value, right? So they're actually having to work out what they need. You can also give them an answer. I used to do this quite a lot. Give them an answer, and what's the question? So, for example, here, serving doggy Rio 18 treats. What's the question? Could be, I had 9, gave them 9 more. You gave some away. There's this one, bottom one, they're like fractions. Had 36, is now eaten half. So by giving them an answer, having to think of their own question, they're used to structuring the language. They're more familiar with the language. So not only taking things away, just give them the answer. What could the question be? And then you can already see how deeper different levels of understanding. Some might do a multi-step question there as well. Okay, it's just here to finish off, just a few question styles. Some of them already covered. Odd one out is on there, for example. Convince me, I've talked about. What comes next, true or false. Just different style of questions. So at the start, effective questioning, I don't think you can just define it as one thing. It's about really mixing it up. If you just did odd one out all the time, it wouldn't be effective. You just said convince me all day long, it wouldn't be effective. But it's mixing it up. But as I said at the start, having a classroom that's used to talking mathematically, that's used to having that idea of that talk, those generic sentence starters, agreeing, disagreeing, talking, allows you to use different types of question. I'm just going to focus on the always, sometimes, never, just very quickly. And one of our concept videos that uses this really effectively. So I'm going to pause. Yes, always, sometimes, never. Have a little look at that one.
Challenge. Is this statement always, sometimes, or never true? If shape A has a greater perimeter than shape B, it also has a greater area. Find examples to explain your answer, and you might also find it useful to use squared paper. This statement is sometimes true. Here is an example where it isn't true. And here is an example where it is true.
So you can see there how it's just once those statements that hope they're going to be used to use those statements, they're having to think. And that one, it was obviously area and perimeter. They're having to know what area and perimeter are. They're having to know how to calculate them, but they're having to use their reasoning. So I think what we need to do is make sure we've got a variety of questions for those skills. Okay, done a lot of talking. Thank you for staying with me. Just a few resources just to show that might be of use to you. So they're all on the reflection document we get at the end with this recording, but things I preferred to that might be of use to you. One are these videos. So we've got them for maths. There's lots of different subjects as well. Key Stage 1 are currently being filmed. They're really useful, a variety of different types of question in there to help fluency, but reads is always a challenge in there. Really great for your class preparation for SATs or at any point, obviously Key Stage 2 and Key Stage 1 when they're being done. We've got a fantastic CPD team, as I'm sure you're aware here at Twinkl. They've got a document here about questioning. I mentioned the pose, pause, pounce and bounce. There's 6 Ps on there. It's another type of question strategy that you might want to use. Obviously, effective questions and effective questioning styles. That's a document you might want to just have a read at your leisure. Having them displayed. Lanyards are really great as question starters. You might have year 6s to go and help out in year 2. They could have these to get the younger children using those questions, have them displayed. What's the mistake? Can you see a pattern? Can you ask a question? Really talking. I taught a lesson once, I was observed, and they were fantastic, but they were too quiet, I was told at the time. I was a bit like, oh, really? They worked really hard on that lesson, but I totally get it. It was years ago. And they were silent. They didn't talk, which was a bit eerie looking back. We want children to talk maths. We want them to have that communication with each other. Bubbles might be useful to get the answer. Spread them around the classroom because you can make similar ones. No, the answer is reasonable because having these questions and structure of answers that they're used to, giving them that generic sentence starters, they've got something that they can use confidently. They know how to structure their answer. These were made after the TeachMeet on Mastery recently. People asked for these. The lanyards again. Lots of the questions I had on the previous slide were on there. They're really useful just to have to jog your memory as well, or if I could have a TA in your class. They're really good to have that conversation. Convince me, prove me. What's missing? That's another good one to have. What do you notice? If you're teaching times tables, the 2 times table, what do you notice about the answers? What do you notice about the 5 times table? It's just, I think it's all the time giving questions to children, having to reason, having to really think and use their understanding, but not just constantly recall. These were the starters of on the question. The perimeter question was from these. Got the key stage 1 as well. They're great. Up on the board, children come in, variety of different types of questions for their fluency, for their reasoning, their problem solving. So they're used to seeing different style of questions all the time. I think it used to be the extension was the problem solve. They should all be problem solving all the time. Otherwise it becomes that big thing that they can't do. They should be doing it from EYFS all the way up in every lesson. You might use some of our schemes, you might not. Our interventions are fantastic. Keep up, not catch up. They're all there designed just to help with questions built in. And obviously our White Rose, Maths Supporting Resources, Diamond to Mastery are great as well. But lots and lots of things.